The 2018 DEB mock paper, and first thing we're going to do is calculate, we're on question 2. So when you have a diameter of 30 millimeters, that means you have a radius of 15 millimeters, height of 40 for the box, inside a closed box in the shape of a cuboid, a cone sits inside it. Find the volume of the cone. Well, volume of a cone formula is 1/3 pi r squared h. So 1/3 pi multiplied by the radius squared, which is 15 squared, multiplied by the height, which would be 40. Put that into the calculator, and you should be able to get 3 pi 15 squared times 40, and long and behold, you're getting 3000 pi. That's going to be pi centimeters cubed, or sorry, millimeters cubed, excuse me. Pi millimeters cubed. Alright, that's part 1 done. Part 2, show an accurate net of the box. Do all your construction lines neatly. So it's 30 by 30. So there's 2 30s and a 40. So there's going to be, how many boxes is there going to be? There's going to be a box on the top and a box on the bottom, and 4 rectangles. Okay, should be easy enough done. So what I might do here is I'm going to use this length to represent 30. Zach and clown. Okay. Oh, sorry, my fault. Okay, actually, sorry, my fault, guys. I have the ability to draw boxes perfectly here. Don't know why I need to use it. All right, that's 1 box. Okay, so that's like the top box. Now I'm gonna do the bottom box underneath it. Should be the same size. So this is a 30 by 30, and this one is a. Now there should always be, if you're top and bottom, there should be how many in between you? There should be 1, 2. There should be just 1 in between you. Okay, and that'd be a 30 by 40. So we got this here. Okay, these are the 2 boxes. Now we're going to put a 30 by 40 in between them. So here is my 30 by 40. Like so, that's my 30 by 40. Now, this is the top box. This is the top, this is the bottom. Okay, so this is the bottom, that's the top. At the back, you have S1, side 1. And I think this one will be S1, okay? Now don't worry about the labels. Now what we're missing is, it's meant to have 6 boxes, okay? I'm sorry, 6 sides, so we're going to have to clone this a couple of times. So Control D, Control D, Control D, and what we're going to do is just going to make ourselves our net, like so. Now it's important you draw on your measurements. Now you can do a big T like this. Big T is what I call this one here, or you can do small t like that. So that's the 2 nets I tend to use, big T or small t. And this is a 30, 30, 30, 30, 30, 40, 40, 40, 40, and that'd be 30. That's 30, and that's 30. Okay, so there is the net of our box, right? An accurate net at that. Okay, now calculate the surface area of the box. Well, the surface area of the box is basically all the individual areas added up together. So there's 2 30 by 30s. So you can do 30 by 30. And then multiply your answer by 2 because there's two of them, okay? Then if we go to the next one, we're looking for the 30 by 40s. There's 1, 2, 3, 4 30 by 40s. So what you can do there is you can do 40 multiplied by 30 to get the area of one of the boxes, and then multiply by 4 to get the area of all 4 boxes, okay? So we got 30 by 30, which should be 900. 900 for one box multiplied by 2, 1800 millimeters squared. Okay, and then next one will be 40 by 30, which is 1200. Then multiply that by another 4, and you get 4800. Add them both together, and we get 6600 millimeters squared. Calculate the volume of the box. Well, the volume of the box is simply length by width by height. So it's going to be 30 by 30 by 40, which is going to be 30 by 30 by 40, 36,000 millimeters cubed. A cylinder height of 20 millimeters has the same volume as the box. Find the radius of this cylinder. Okay, so the volume of a cylinder is pi r squared h, and it has to equal the volume of this box, which is 36,000. Okay, so this means pi times radius squared multiplied by 20 equals 36,000. Radius squared on its own, it's been multiplied by pi and 20 on the left, and when they get transferred to the right hand side, they'll turn into division. So it'll be 36,000 divided by 20 pi. 36,000 divided by 20 pi is 572.96. 572.9577. Sorry, and then we're going to square root that. Root answer. It's going to be 24 millimeters to the nearest millimeter. So when you square root it. Okay, I believe that's us done with this. Okay, so that's question 2 done. Now we're on to question 3. We're just going to put down these 3 points here. It's going to be A is going to be 0 minus 3 by the looks of it. B is going to be 4, 1. And C is going to be minus 3, 4. Okay, then I'm going to take these measurements and bring them to the next page. Okay, so put next page, here it is, and I'll try and paste it. There we go. Done. All right. Find the coordinates of the midpoint of AB. So the midpoint of AB will be, use the midpoint formula. So we have x1 plus x2 over 2, and then we have y1 plus y2 over 2. So it's going to be 0 plus 4 over 2. Then it's going to be minus 3 plus 1 over 2. 4 over 2 is 2. Minus 3 plus 1 is minus 2. Over 2 is minus 1. Find the equation of A to B. Now to find the equation of A to B, we do the slope formula. So we're going to have to do y minus y1 equals m into x minus x1. Now you can use either of the 2 points that are on the line. You can either use point A or point B. I'll use point A because I already have it labeled as x1, y1. But we're going to need to find the slope. Okay, so we're going to write down the slope form as y2 minus y1 over x2 take away x1. Or you can just write it as a blank slate like this. So you can use that in your calculator, where you're just keeping the brackets blank. And what we're going to have here is 1 minus minus 3. The next one's going to be 4 take away 0. That's x2 take away x1. Put all that into the calculator. Press the fraction button. And you can see we're just preparing the question. So we got 1 minus 3, and then we got 4 take away 0. We get an answer of 1. So the slope is 1. So it's going to be y, take away y1, which we all said we'd use was minus 3. So y minus 3 is y plus 3 equals 1 into x, take away x1. And x1 is 0 in this case. So I get y plus 3 equals x. You move the x over to your side and you get minus x plus y plus 3 equals 0. That's the acceptable answer, or multiply both sides by minus 1 to get this answer here. Okay, that my preference is to have x positive, but it's not necessary in some cases. Now D, the line K passes through C. The line K passes through C and is perpendicular to the line AB. So the slope of AB is 1. A perpendicular slope to that would be minus 1, because you have minus 1. You have to multiply the two slopes by each other to get minus 1 if they're perpendicular. So 1 multiplied by minus 1 is minus 1. Okay. Find the equation line K in the form ax plus by plus c. Okay, guys, so what we're saying here is that the point C is minus 3, 4. So we know a point that goes through, that can be your x1, y1, because C is on this line. Okay, so what we're going to say is y minus y1 equals m bracket x minus x1. We're then going to say y minus 4 equals minus 1 into x minus 3 is x plus 3. Y minus 4 equals minus 1x minus 3. Move it to the left. X plus y minus 4 plus 3 is minus 1. Okay, x plus y minus 1 equals 0. Investigate whether the midpoint of AB is also on the line K. So the midpoint of AB, which we found out earlier, is 2 minus 1. So this is 2 minus 1. And we have to see if this point is actually on this line here. So what you do is you replace the x and the y value of the line K with the coordinates you're given. See this x and this y, you have to replace it with 2 and minus 1. If it balances, it's on the line. If it doesn't balance, it's not on the line. It is on the line K. Or 2 minus 1 is on the line K. Alright, great. Caused it to balance. Oh, there's an F as well. Alright. Using the information above, state whether or not the triangle ABC is isosceles. Give a reason for your answer. Well, I'm going to need something to picture this, so I'm going to have to go back to my original diagram. Okay, so what we did at the very start was we found out the midpoint of AB. We know that the midpoint of AB is this point here. Okay, we then know the equation K is perpendicular to AB, which means it hits at 90 degrees. However, it also goes through the line C, and it also goes through the line B. So look, the line K is a perpendicular bisector to AB. This would mean that it is an isosceles triangle. Both triangles would be, yeah, I suppose we could use I'll do the proof here, because I probably need to look at the diagram while I'm doing it. So I'm going to transfer F and G to my page here. Give me a sec. Okay, and paste it here. Now, using the information above, state what ABC is isosceles. Give it a reason for your answer. Okay. The answer is yes. And the reason would be is that the line K is a perpendicular bisector. Now what perpendicular bisector is, is the perpendicular bisector. See the way it goes 90 degrees here, and it crosses through the midpoint of AB. Line is the perpendicular bisector of AB. Since point C is on this line, is on the line K, it is equidistant, which means equal distance to points A and B, hence triangle is isosceles. Okay, now G. The triangle AMC is the image of the triangle MBC under a transformation. Write down this transformation, give a reason for your answer. Okay, AMC, which is the left one, is the image of the triangle MBC. So essentially, how do you turn this triangle here? How do you turn the yellow triangle into the blue triangle? Okay, that's essentially what we're trying to find out here. Now, the only point that changes, M and C are in both triangles. So the only point that changes is that B turns into A. So it's a axial symmetry in the line K. See, every point in B gets reflected through K on the other side. See, every point is getting transferred from here to here over and over again. See, it's just mirror imaging. It's a mirror image axial symmetry in the line K. Okay, because M and C go nowhere. M and C don't change position because they're in both triangles, so that means M goes nowhere and C goes nowhere because they're actually on the line of symmetry. So what we say there is axial symmetry in K in the line K. And what you can say is B turns into A, M and C don't change positions. Because they are on the line K. And the line K is equidistant, which means the same distance from points A and B. Means it's the same distance from both of them. So you go back to the top, this distance here from the line K to B, and then the line K to A, it's the same distance. In axial symmetry, you travel the same distance towards the line and the same distance out the other side. Okay, man, that was a hard 2 questions to start off, so this is a tough mock. Now, it doesn't get any easier with the looks of it. Sometimes. The plane surface of a standard snooker table is 11.7 feet by 5.8 feet. Given that 1 meter measures 3.3 feet, find the area of the plane surface to 1 standard 2 meters squared, right? So here's what we're going to do. We're going to say that 3.3 feet equals 1 meter. 1 foot equals 1 meter divided by 3.3. Then 11.7 feet will be 1 divided by 3.3 multiplied by 11.7. So 1 divided by 3.3 is 1 foot. But I don't want 1 foot, I want 11.7. So I'm going to multiply that by 11.7. And we get 39 over 11, which is probably our better answer there. So 39 over 11 meters. Best to keep it in fractions if you can, or you can say I would use 3.454. You can use that as well if you want. 545. Okay. Next thing you have to do is find out what 5.8 feet is. So it's going to be 5.8 feet equals 1 divided by 3.3 multiplied by 5.8. And we get 58 over 33, which is 1.7575. So I'm just going to use the fraction 58 over 33. No, meters. Now, area of a rectangle is length multiplied by width. So I'm going to do 39 over 11 multiplied by, what's it, 58 or 68? 58 over 33. So here we go. 39 over 11 multiplied by 58 over 33. And what we get here is 6.23. Corrected 3 significant figures, so 6.23 meters squared. Okay, done. Next one. An equilateral triangular frame with sides of length 30 centimeters is used to set the 14 red balls at the beginning of the game of snooker as shown. Using the theorem of Pythagoras, calculate the value of h. Okay. So what we know is it's 30, and that's a 30. And in isosceles and equilateral triangles, you can cut down the middle like so. Okay. And that means that we're cutting that into 15. So the height h is going to be 30 squared equals h squared plus 15 squared. And then 30 squared, which is 900, take away 15 squared, it's going to be 675. So 30 squared minus 15 squared when you bring it over is 675. That equals h squared, square root it. You get 15 root 3, or 25.98. Okay, centimeters. Okay, let's move on. Hence or otherwise find the area of the triangular frame. Give your answers in centimeters squared. So to get the triangular frame, what we're going to do is we're going to do a half base times height. So it's going to be a half 30 times 15 root 3. Half base, which is 30, then times the height, which I just got, which is 15 root 3. Be a half 30 times 15 root 3. $389.71. Now to one decimal place, 389.7 centimeters squared. Okay. Now what's next on the menu? Prove using trigonometric ratios that the angle inside the triangular frame is 60 degrees. Okay. So what would have happened a second ago was I calculated the height. So I know this is not an equilateral triangle, but you get the gist. This is 15 root 3. And we know that this is 30. So we can say that this is x, and I can say that sine x is opposite over hypotenuse, which is 15 root 3 divided by 30. Then I can sine inverse that to try and show what the angle is. Shift sine inverse 15 root 3 over 30. $60. The standard snooker ball is in the shape of a sphere of diameter 5.25 centimeters. Find the volume of all 15 red balls. So this means radius is 5.25 divided by 2, which is 2.625. Okay. So volume of one ball is going to be 4/3 pi r cubed, because that is the volume of one of them. Then when I'm done with that, I'm going to multiply by 15 to get the answer of 15 of them. So we'll just do it all in one go. 4/3 pi, shift pi, multiply by 2.625 power 3, and multiply everything there by 15, and we get 1136.5. 1136.5 centimeters cubed. Okay. E. Assume that the triangular frame is the same height as the red snooker balls. Express the volume of the 15 balls as a percentage of the internal volume of the triangular frame. Give your answer to one correct place. Oh my god, this is a tough question. So it's an interesting question. So guys, essentially what you have is you have a triangular frame, okay, and in the triangular frame, what's happening is it has a certain height to the triangular frame, okay. So the volume of your triangular frame is essentially, it's your area of your face multiplied by your height going backwards. Now, it's the same height as a snooker ball, so it means that it has to be 5.25 centimeters. So h is 5.25 centimeters. Now the area we got earlier, we got it as in part B, I believe, 389.7. So the face is 389.7 centimeters squared. So 389.7. Now, basically the volume of the triangular thing is going to be the 389.7. It's the area of the cross. It's the area of the face of the object multiplied by its depth or its height. Now, this answer should be bigger than the balls, the 15 balls. Otherwise, you've gone wrong somewhere, because it's got to be 389.7 multiplied by 5.25. 2045.925. So 2045.925 centimeters cubed. Now, it wants to express it as a percentage. So you're going to divide by 2045.925. You're going to put the answer of the 15 balls. So how much space does the actual balls occupy? 1136.5. 1136.5. It's around 50%. And if you were to look at the area, you can see that on the diagram of the snooker balls. You can see there's a lot of area here, and these green areas all add up and you actually find when you add them underneath, and you got to remember this is a two-dimensional object. This is just me doing the area, but you forget that not all of this is touching the top either, so it's a significant amount of space above and below the spheres that contribute to only being just above 50% ish. Okay, so what we have here, you multiply this by 100 to turn it into a percentage. So 1136.5 divided by 245.925, then you multiply that by 100 to find out the percentage, 55.55%, and I just want to round it off correct to one decimal place. We've got to be careful here. It's not 55.6, it's 55.5. The 49 rounds down, so 55.5%. Almost made a mistake there, but there we go. Okay. Question 9. So question 9 is we want to draw a perpendicular bisector that goes through K but also goes through A. Now the first thing we need to do is we need to find two points that are the same distance away from A that are on the line K. So fix a certain compass length, doesn't matter what the compass length really is. I'll just draw up here just to bring my compass down. So I'm going to come down here like so. I'm going to go all the way through. And these 2 points, which I'm now labeling B and C, they are the same distance away from A because they're the same radius. So that's B and that's C. Now what I can do next is I'm going to get the perpendicular bisector of BC. And what you should see is it should go straight through it should go straight through A, because A should be directly above the midpoint of BC. Essentially, it's like an isosceles triangle that we learned earlier. Okay, so we're going to stretch this out. We're going to do the top and bottom. So there's one big dash there. Then here's the other big dash here, like so. Now, what we're going to do next is I'm going to go to C. I'm going to do the same procedure up top and bottom. So there's the point of intersection that actually hits A for some reason, pure jamminess. Actually no, I used the same distance, that's why. And then, so your one doesn't have to, you can use a different length and it should still work. Okay, see these two lines here? I'm going to draw a perpendicular line straight from one of them to the other one. And this line goes straight through A. Or should go straight through A. You can see I'm slightly off here. See here, I'm slightly off. I just need to move it ever so slightly to the left and probably a bit closer to A this time. Yeah, I'm pretty close. Okay, so that's it. Question 10, guys. This is on your proofs video. I'll load that up. Remember to fill this in and use the proofs video. Find it in the proofs video to do it. Okay. And then finally, question 11. Find the diameter of the circle. It says the area of a circle is pi r squared, which equals 121 pi. Pi's cancel on both sides. R squared equals 121. This means radius equals 11. Okay, so we got a radius of 11 for this. Find the values of x and y in the diagram. No bother. X is going to be double 54. So x is 108 degrees because they're both standing on the same arc. X is at the center of the circle while the 54 degrees is on the circle. Now if x is 108 degrees, then 360 take away 108 should tell you what y is. At 252 degrees. Okay. Now, right angle triangles ABC and CDE are similar. Okay, find BE. Now, what I always say about these ones is draw the triangles out separately to each other. It makes picturing the whole thing a lot easier. So what I've just drawn here is I've drawn CDE, and on the other one I've drawn CAB or ABC. Now we know that the red angle is the same. Red angle. We know the blue angles are the same because they're corresponding, and we finally know that the purple angle is the same because it's the same angle. Now what we know is that this is 11, and this is 6, and this one's 9. Now compare the 6 and the 9. Large divided by small. Basically the larger triangle is 1.5 times bigger than the smaller triangle. So what's 1.5 times 11? 11 multiplied by 1.5. We find out that that's 16.5. So if the whole thing is 16.5, this means E to B must have been 5.5, because 5.5 plus 11 is 16.5. So 16.55 take away 11 is, sorry, 16.5 take away 11 is 5.5, and you also have to put in 11 multiplied by 1.5 to get 16.5. Okay, that's done. Answer is 5.5. Using trigonometric ratios, find the angle A to B to C. This blue angle here, that's no bother. We know the adjacent and the hypotenuse, so we use cos. Cos x is 9 over 16.5. Cos inverse this, opposite over hypotenuse. Shift cos inverse 9 over 16.5. And you get 56.94. So 56.94 to one decimal place, 56.9. Okay, and lads, that is, I think that's me. Yep, over and out.